All right. So this is actually I know the class will be scanty today, especially for those that will be trying to connect from Nigeria. Expect that some of us will be having issues, especially those that don't have satellite connection. Most of the ISPs there, they've been corrupted. All right, welcome everyone once again to um, this session. Happy New Month. I know it's the third day already, but we just been meeting for the first time this month, uh, and I trust the week went well. Yeah. So we are starting officially the cloud module of this boot camp today. And I've termed today's session Cloud Computing 101. So we would, uh, I know most of us, well, I think all of us, I'd say, already in a way have interacted with AWS. And this was, you know, um, planned, well, as part of the curriculum for this bootcamp, so that by the time we get into the cloud computing session, we don't really spend time on setting up and all of those things. Yeah. So, but moving on now will be. We only provisioned one Linux, instances, to aid us in the Linux, would I say, recap session. I don't see the Linux sessions a session as a full module because just a recap of all, well, a foundational kind of module. And I hope and I trust that we all are in a way familiar with the terminal already, because moving forward we would be using it both in every other module, as in this boot camp. And so it was necessary that we went through that phase to introduce those that are not very familiar with Linux shell or terminal now, to know that we'll not be working uh, in the GUI. But for this cloud computing module, we'll be spending most of our time both in the GUI, and we'll be mixing when we need to uh, use the terminal. Would bring up that terminal, and then we would be learning different services in cloud. Yeah. So welcome once again, everyone. And again, this is Stern Cloud Computing 101, because we'll be taking it from the very beginning. Yeah. We'll learn. Uh, I'm not going to assume that we already have people that are cloud practitioners here. We have a diverse audience, so like as much as possible to carry everybody along. And just as a caveat, I know learning cloud computing as a whole in a month is an Herculean task, but I can assure you guys that what you need, to be familiar with the services that you need to be familiar with, the foundational knowledge that would aid you in, that you can build on. Uh, you will get that. That you can even, get into a room where they're talking cloud computing, and you can confidently also be part of that conversation. Yeah, that's my goal in this module. Yeah. So once again, welcome those that are just joining. You're welcome. And yeah, right in the center of my TED talk, as my manner is, I always like to uh, first, feel like uh, the celeb that I just thought of now. Let me just keep it to myself. But again, welcome to my TED talk. So the cloud is a new frontier. But the new frontier, it's not a new frontier because it's actually been around for a while. Yeah, even before I it chose me, it has been around for almost a decade. or close to a decade before I was introduced to it. Yeah, so but it's the new frontier in the term that everything is moving to the cloud. If it has opened up a world of possibilities. New the way technology is advancing now is as a result of um, the cloud computing. It has made uh, um, you know provisioning and exploring services that ordinarily you would have to, for you to take advantage of or use now. You need to have probably a mini data center in your house to be able to configure those softwares or services. But with the cloud now, everything has been simplified. You don't have to worry about having infrastructure, whatever your use case is. If you want to, have a high performance computing right from your living room on your bed there, you can set up a very powerful cluster of machines that would help you do whatever, if it's data models you want to analyze or whatever. So it has opened up so many things. It's a very vast and ever-changing landscape. Yeah, very, very vast. If you go to every of the different, even the very smallest of cloud providers now, they have dozens of services. They keep expanding, and new things day in, day out. AWS and their reinvent programs, they keep introducing new things, and it's almost becoming overwhelming, especially if you are very inquisitive and you want to try to put your hand in everything. It can get really overwhelming. But it's full of opportunities because of the ever-changing landscape, and then um, our ability our willingness to learn, you know, actually opens us up to that world of possibilities, opportunities that the cloud is offering. And so there is actually no limit to what we can achieve in the cloud, um, except, okay, yes, can't actually literally take us, into the, um, the physical cloud or even to heaven now. But in terms of technology, the technology space, there's no limit to what one can achieve. Yeah, whatever it is that you want to learn. Yeah, if you're interested in, say, AI, in um, data, just whatever it is that you can think of. If you're into research, everything you need has already been kind of pre um, configured for you. All you need to do is just go take advantage of it. Yeah. So we will be building on this um, landscape of this vast world now. And I'm happy that you guys are here. You're in the right place. And I will try as much as possible to preach cloud computing to you guys. Um, I'm an advocate for cloud computing. I was I was interviewing for consulting role, a few months back, and then they were so particular about setting up their high performance computing, well, getting a data center, and I just kept trying to move this. Say, why do you want to? If you look at the total cost of ownership, it's not going to be worth it on the long run. But they were so apparently they just wanted to set up their own data center, and but I will try as much as possible to preach the cloud to us and guide us into using the cloud both to achieve things and also be safe in the usage of of the cloud, because as beautiful as it is, it also exposes one to so many things. Yeah, so welcome once again, everybody. This would be our agenda for this week. Uh, a bit. I think we probably would cover a few today, especially the first three. session, and then these two parties that won't even take time. So probably hard to this agenda moving on. Well, by tomorrow's session. Yeah, so we'll be starting with. I realized I think we um, did a brief introduction to some networking things during the not foundational sessions. Yeah, but moving to the cloud now, there are a few things I probably did not touch on, which would briefly introduce us, and there are things that would, in a way, would be like leverage to better grasping some cloud terminologies. So for the first two items there, I put in front that they are very theoretical. So it's going to be talk. I know. So this module is supposed to be a kind of hands-on. That's the best way to actually learn, And I know I keep saying this. Uh, it is when you actually use things that you understand it better. And so the agenda, not just the agenda for today, but for the um, 4 weeks that we're spending together is going to be project based. Yeah. But before we jump into start, working on projects, we need to know what we are, why we are working on all of this project, what the things that make all of this. So we'll be talking some theoretical things, and then we'll jump into, yeah, practical things. By tomorrow, we should, start. Tomorrow is just today again. Be talking some networking things, some um, uh, cloud things, networking things that terminologies that make the cloud a possibility. And then we'll get started with cloud computing. Talk about what is cloud computing, the various cloud deployment models, and then uh, types of cloud services. There are some of those. I'll pick a few of those, and then so all of these things are, what you guys would need to start building your vocabularies of cloud computing on, so that when you get into any setting and then they are talking, they're discussing the cloud, you're able to both contribute and then uh, um, understand what they're talking about. Because if you're in a room and then they're throwing out terminologies here and there, and then you have not, heard of those things before, it's just going to be gibberish in your ear. So yeah, as much as theory can be boring, but to me, just listening to a bunch of things, yeah. But I try as much as possible to, especially when I'm learning new things, I can't overemphasize taking notes of new terminologies, and then if need be, if I don't have the opportunity to ask questions, on the go, on the fly, there, go back and then look up those things so I can better understand, and um, things that were talked on, during that session or whatever would now make more sense even after the session has ended. If I have opportunity to go back to the videos, and then it will make more sense after I understand those few terminology. So now you need to start for this theoretical part, there are terminology that you need to start getting familiar with. And for those that would want to start interviewing as soon as possible, the things we'll be talking about here are the things that, you'll be taking into the interviews as fundamental things. It's a privilege to interview someone one time, and then my engineering head, at that time, just asked the potential DevOps guy was should describe a few cloud deployment models, and it was just here and there, as basic and as fundamental as those things are. And so many of us actually want to start from the most advanced things, and then we neglect the foundational, the things that would even give us more understanding of those advanced things. So we'll be spending time, talking about all of this, and then talk about cloud providers. We know them already, but oh yeah, so the time we'll spend on the things that I'm going to assume that we know. I'm not going to be assuming that I want to believe there are people here that are still new to some of these things. So try as much as possible to carry everybody along. And then we'll look at a few careers in cloud, which I think is very, because like I said, it's a vast field. And so we need to know where we should start from, and look at way um, all of these different opportunities and see where our strengths are. Okay, yeah, if I know I have a flair for helping solving problems, this is the role I need to go for, and what have you. And if time permits, also take a tour of the console and some look at some of the AWS services that we will be learning, as part of this journey. Um, and the rest of this would, catch up on them as we move on. Uh, I hope you guys are still with me, and I would say you should. It should be, because you don't. I don't want to be the only one talking for 3 straight hours. So will be. I would expect that you guys would um, be a part of this conversation. And I keep saying, I'm not an island. I don't know all of these things. So if I say something that you think is not completely correct, please immediately call me out. I'll really appreciate it. So I can also learn. I always come to this session, even though prepared. I always come hoping to learn one or two things from. I've had to train people that are, you know, I'll say even more knowledgeable than me in some areas, yeah. And then when they speak, I immediately bring out my notes and then take notes, yeah? And I use that in other places, So please, let's make this as interactive as possible, and then yeah, moving on. Yeah, I'm just going to be the pilot. You guys would need to fly this plane together. So nobody has confirmed that you can hear me. I feel like I've just been talking to
Yeah, we
myself.
can hear you.
All right. Thank you very much, Benumi. Welcome.
Yeah,
All right. All right. So let's move, let's get started. Like I said, we would begin by looking at some networking um, concepts overview, just some terminologies that we've already again I already talked about servers, workstations during the um, Linux part, but now I want to I'd like to um, kind of paint a picture of um, what we would be moving to, where we are, well, where we were, and then where we're moving to, basically. So I'm going to stop sharing this, and I'm going to bring up a whiteboard. Uh, hmm, this new Zoom, everywhere, everything is just everywhere. Where is my whiteboard? I found you. Yeah, in whiteboards. Uh, Let me just start a new whiteboard because source failed. So you guys would bear with me. My network can kind of be epileptic. Uh, this has been going on for a few days now. I don't know who will be offended in this country. My whiteboard is not loading. This is not going to be possible without not loading. What to do? It's not loading. Existing whiteboard. I don't want to show an existing whiteboard though. Hmm. All right, I think I fixed this. Please let me know when you can see the whiteboard. Can you guys see my whiteboard?
I can see your screen. I can see your whiteboard.
Okay. Who is writing on the whiteboard? Hey, you want to take
Okay.
over this class?
Sorry, I'm the one. I was just seeing what I can do.
Okay. All right. So I'm just going to try as much as possible to, again, make this very, very brief because we have quite a number of things we want to actually touch on. And I know probably some of us are familiar with this, but please bear with me while I try to carry every other person along. So I just want to kind of depict what an enterprise network is. So an enterprise network refers to the physical, uh, virtual kind of, yeah, and logical connectivity of infrastructure that enables system and apps to communicate at an enterprise, an organization. Yeah, so it comprises of hardware and software systems and different communication protocols. I won't be delving into full, not taking us through a full, data communication. We're talking about some deep things that probably would never come in contact with, except you're trying to uh, um, be a networking person. Yeah. So we'll just briefly, and you pardon my drawing also. It's kind of very hard to uh, draw with your mouse. So in an enterprise. So this is going to be an enterprise network now. I think we already mentioned, and a network is basically two or more computers, connected to share information and run services, to communicate basically. So this is an enterprise network. We'll So the network here is basically having different computers talk to each other. So inside of an enterprise network, we have quite a number of things. We have different workstations, both uh, PCs. We have desktop computers. They are connected to they are both physical and logical virtual infrastructure. So we have an infrastructure that is called a switch now that's used as part of a network. We have different ports in here. All right. So this PC1 is connected here, and we can even have a printer somewhat. So I don't know how to depict what a printer looks like, but this will serve as a printer. Yeah, so we have the printer in here. So if PC1 and computer one want to print, they can, take advantage of this. Again, we can have multiple, uh, you know, computers. All of them, they're connected to this. And take this up a bit. For You can't see my screen. Dan can't see my screen. Aside Balloon that said this, so he can see my screen. Is there someone else that can see my screen? Dan, it may be your network connectivity. Who else cannot see my screen?
I can see
I
us.
can see your I can see your screen.
So Dan, it probably is your ISP that your bandwidth maybe drop off and then join back, and then see if you'll get better. All right, so we inside of all of this, so right now this network is just very internal. All of these PCs, they can only communicate, amongst themselves. Yeah. Is isolated, but for an enterprise network, they probably will probably have different. So this can be Australia, the Australia region, or the Australia site of the organization. There can be a site in New York, and then they need to be able to. We have set of infrastructure also in here, so there is a logical connectivity infrastructure. It's called router now. Router. It can be like this. Since my so we have a router sitting at the edge of um, an enterprise, an organization's network now that allows it to connect to. So router is more like, would I say, like a gateway, to out of your network. So switch is connected to this. So with this kind of architecture, this PC now is able to, connect to various internet and services, yeah, and vice versa. And then they are able to also, use the internet as a backbone to, share information, communicate with the New York site of the organization. This is what a typical organizational network now look like. All the systems are able to communicate and then retrieve information. Uh, yeah, so in most organizations, yeah, even if their employees even have to work from home, they can also still, communicate. Talked about the different kind of let's say computing hosts that we have now, where we have servers that actually provide some form of service. Usually it is like that in organizations. They have storage servers, they have email servers, they have all sorts of servers now that provide some form of service to all of the different users. There can be tons of users now, you know, uh, and so usually organizations actually have what we call data centers now, usually attached to their building with racks and stacks of, computers. Yeah, so we have like a data center here. This would house some of all of the different servers now. Uh, for storing different data that the organization generates from day to day. And then every site would have its own data center attached to the building. Yeah, and this comes at very, very great cost. Yeah, to any organization that has, imagine organizations that have branches in different continents, even in different states inside of one country. It means they have to set up data centers, and setting up racks and stacks of computer can be quite expensive. You have to budget so much and then think about the future while doing all of this. Yeah. So, but what makes even this possible is what we are very particular about: the ability to take a computer hardware now. So this will take me to another. So we can take a computer hardware So so a computer hardware basically consists of storage, and storage, the RAM, yeah, and the CPU. Those are, basic things. I'm just going to stick to those three now. And then we have the operating system also in here. Yeah. So because an organization can have different services, different need, different servers that needs to be used. Yeah, different applications, that's they use as from for day-to-day running, or if they have organized other integration, services that they run to. This having to have set up individual servers to house all of those different services, was not very, very practical. So there is a technology, yes, that allows a computing. So this is a computer now. Yeah, it's a computer or a server, whatever you want to call it. Yeah, that allows a computer, to be able to run multiple simulated environments, or kind of to dedicate resource to now can have concurrent operating systems running on a single infrastructure. So even our local machine, the one in front of you, we can virtualize it and then say aside my Mac operating system that I have now, I want to have Windows also running alongside my machine, so I can actually virtualize it. So that's the word. So I can virtualize. So it's a technology, virtualization, the ability to, it is basically a technology that allows us create multiple simulated environment. But for this virtualization to be possible, you'd need an hypervisor, is software, that allows you to split one system into separate environments. So we have an hypervisor in here. Hypervisor. So this hypervisor would be in here, and then it allows you to have what we call virtual machines. Yeah, like a virtual environment. Albeit inside of this virtual machine, each virtual machine can have its own operating system in there, and then a suite of other different applications that you want to have inside of that. These virtual machines actually take advantage of the overall hardware that this computer actually has. So if you have storage of 1 TB in here now, you have RAM of say 48 gig, and then you have maybe 16 core CPU, all of this now for every, so if you have multiple virtual machines in here with their own, distinct operating system, yeah, each of these virtual machines now would be taking resource from this hardware. So this base hardware must actually be strong enough. So for your PC in front of you, if you try to virtualize with, you want to have multiple virtual machines running at the same time on it, overall, the performance of that machine would, start degrading. Yeah, you probably would not be able to run things smoothly. Yeah. So so this actually is what most organizations use to host their suite of applications now. Yeah, serve and yes, a suite of services inside of the data center. You just have racks of servers. So for those that have not seen what a data center looks like, you can quickly do a Google search and see what a data center looks like. Yeah, and for those that have been privileged to work in it, I know you know what I'm talking about already. So this is so we have different types of hypervisors now. I put this, not all hypervisors actually need an underlying operating system. So this depiction that I did is just to help us. You are taking it from the standpoint of our local machine. So we have two types, generally two types of hypervisors. We have type 1 and the type 2. For the type 1, type 1 does not actually need an operating system, to be installed before it gets installed on top. So they are kind of bare metal hypervisors. They run directly on that host. So I think maybe host would be a better word for this. The host computing systems on the hardware directly, and then it can now controls the hardware. Type 2 is what we probably as end users are more familiar with. A um, you know, it actually works, is installed on top of an operating system. We have VirtualBox, VMware, and the likes of them, that we can use to virtualize our machine. Yeah, but so now the meat of all of this is for cloud computing now to go to cloud computing. So with all of this now, with this little knowledge, so virtualization is the technology now. Virtualization that actually helps organizations to be able to set up their data center to stack servers and then use that servers to be able to run multiple applications and then have different services, run inside of just one, maybe large host computer now. Yeah. So, and also virtualization actually makes cloud computing, possible. Yeah. So for cloud providers, they actually take advantage of. So for each cloud provider now has its own, has different data centers. So we'll see this now, but just take note now that virtualization is the technology that makes cloud computing actually possible. Yeah. So um, to again simply put this, virtualization actually can make one resource, this one computer now, act like many. So we can have multiple resources in there. So it's the technology that allows you to create multiple simulated environments, and dedicate each of them, to run a suite of things, Uh, yeah, so I'm even surprised that my network is bad. That allowed me to join this meeting today. All week I've been struggling with network, unfortunately. But maybe when you go back to the video, then you are able to see and then the whiteboard. So far, are there any questions? Do we all understand this very? Yeah, I don't want to say scattered depiction, yeah, or this is my best efforts to try to explain this. Uh, okay, so
I think, hello.
yes, Balloon.
Yeah, to an extent, I understand what you're saying, but I'm trying to get an understanding of this diagram. This diagram you are trying to use this diagram to explain virtualization, right?
Yes, and how it
Now,
makes both our enterprise network be able to set up their data centers and also make the make cloud computing possible.
basically like simulating several computers.
Yes, with inside of just
Okay.
one
One
computer.
on hardware.
Yes, one hardware.
Okay. Okay. I think I
To
get
bring
it.
it.
Because I'm trying to what?
Yeah, go ahead.
I'm trying to understand your explanation on hypervisors too. You said you have two types of hypervisors, type 1 and
Mm.
type 2.
Yes.
You said type 1 is bare metal, that one is installed directly on the hardware, right?
Yes. Yes. We
Instead
don't
of having
need
instead of having the hypervisor installed on the OS.
yeah.
Okay. So that means this first diagram can be like type 2.
Yeah, this is type 2, obviously.
Type
This
2.
section
Okay.
is a type 2 hypervisor here because it's sitting on top
This
of an operating
of the
system. Type
OS.
1, we just have
Okay.
the hypervisor sitting, they call it a bare metal hypervisor. And that's what most
Sit on the hardware.
organizations use because with operating system now, there is an extra layer of, you know, complexity. But type 1 hypervisors, you control the hardware directly.
Okay.
This again abstracts a few things away, gives it more flexibility and ownership of the hardware. Yeah.
Okay. Yeah, I just want to be sure I understood what you said. Yeah, thank you.
Yes. All right. So as fundamental as these things are, if you understand them, yeah, you both are open to even managing data centers because anybody that wants to manage data center will be working extremely, with hypervisors and then, creating virtual machines and what have you. Now, with the advent in technology, we are talking about containers now and then, yes, containers and what have you. Containers are basically, so our virtual machines are containers in a way. Yeah, but now we have Docker as a technology that helps even containerize, virtual, environments, in a very lightweight version that doesn't really put a strain on the hardware. Yeah, but that's in later version. Yeah, well, uh,
Okay, you don't want to talk about that
no,
much
no, no,
right
no.
now.
That's going to take us off
Good,
tangent
good.
now. Yeah.
Okay.
Yes.
Okay, because I wanted to pitch in something though, but since you're not saying anything,
No,
okay, no problem.
don't let us. So our goal is to understand the cloud, and that's why I want to just stick to, uh, you guys understanding this terminology. So I've seen not even technical, all these tests now, that they give cloud engineers different roles. And, I've seen quite a number of them that just wants to know that you understand what makes, the cloud possible. As simple as that question is, yeah, I can, give you a role. Yes, Angela, I see your hands up.
Yeah, please can you kind of elucidate more on the like correlation between virtualization and cloud?
Okay. Okay. So it will make more sense when we start talking about cloud servers. But for every, I had to draw this. So say for a particular organization now, their data centers now is made possible using virtualization. So let's say even this enterprise, this picture that I have here is owned by AWS. Okay, no, that will not work. So what cloud providers do now is they have massive um, uh, data centers, with racks and stacks of computers, and what's the end users of, cloud providers, what we as cloud users do now is we go inside of AWS now. We just we rent spaces in there instead of having to set up our own data center, we go to the cloud. They have massive data centers set up globally, in different parts of the world. So depending on where we want to set up our data center, we even have organizations that partner with AWS, and then they say, okay, inside of your data center, we want to take advantage. We need a full rack. We don't want because if in a full rack now you have, I think it'll be safe to show us. Let me help you guys and come up with data center.
Is that like
So I can't see your screen again. Oh.
Yes, I stopped the whiteboard. I want to show us.
Okay, I was laughing because I pressed something. I thought I was the one that stopped. So is it that you're talking about the PaaS, SaaS, and software as a service,
no,
platform as a service?
we've not gotten there yet. We will talk about all of those now. Now
Okay.
I'm just talking
Right.
about the data centers now. So this is a picture of what a data center looks like. So this is a large building, and each of the things we have in here are different servers. So inside of these servers now, there are hardwares, and then they've been virtualized. So virtualization is inside of all of this, each cloud provider, they have, this kind of setting in different parts of the world. And then all of the services that they offer you, your compute service, your storages, your databases, they all kind of are, they are sitting inside of each and every of this. You can have RDS as a software or as a service now, it's sitting in here. Yeah. So as a user, you have an interface, which is your console now, that grants you access to whatever region now. We'll talk about all of these things in a bit. Yeah. So for each region, you have all of this, and then you have availability zones inside there also. So you can connect using your internet, your console now, to any of this and say, okay, yes, I need space inside of this your large data center. Maybe so for organizations that want to have the capacity, they can decide, okay, yes, we want all of this rack and stack of servers now, want to use for our suite of services, want to store our data inside of this. Yeah. So what makes this possible is virtualization. Yeah. Instead of having just one, a very large rack stack of computers now, and then is assigned to just one person. Yeah, we can have multiple tenants in here with different services running inside of these things. Running inside, say, their own container, virtual machine. And if it's so even when we talk about, if you want to have a full network, a custom network now, all of those is made possible by virtualization. The ability to take one piece of hardware and then make it several hardwares in a way. Yeah. I hope that answered your question in a way, Angela.
Yes. Thank you.
All right, cool. Okay, so let me see. I think, okay, yes, we would get started with cloud computing now. So I'm just going to throw this out there. Is there anybody that has that wants to take a shot at what they think cloud computing is? I know they are. I don't want Google answer. I just watch your understanding now. I know I've probably when I was explaining this data center, mentioned one or two things, but yeah. Anybody want to give a shot on what they think cloud computing is before I, start giving you my Google answer? Nobody? I know you guys know now. Please, let's share this knowledge so I can take.
Yeah. So, sorry. Good evening, everyone.
Good evening, Mr. Hartford.
Blessing on the line.
Oh, sorry, please.
Okay.
Please go ahead. I
Yeah.
thought.
Okay. So I think my own literal understanding of cloud computing is basically uh the ability for you to um run your applications and services over the internet.
Yes, perfect. So yes, you run different applications, services. Services is the right word over the internet. So is there anybody that wants to still say something else? I saw that
To me, I would say is the ability to access and be able to utilize our computing services over the internet without thinking of cost of hardware, cost of other facilities and stuff that has to do with setting up a local server and having to do this without thinking the cost of storage, database, networking, software analytics, and all of this stuff. So
yes.
leaving the responsibility to the cloud IOC, that's the cloud providers.
Yes. Yes. So that's good. I see that we have knowledgeable people in the building. So yes, I don't think I can actually give a description or a definition of cloud computing that can go beyond all of those. But I have a slide deck that will guide us through, or that we'll be talking about, in this remaining session here. So all of this case style with cloud computing, I have a slide deck that will be using as a guide, kind of, I just walk us through it. Going to bring that up here. Other minutes. Bring this up. Yes. So what is cloud computing? Yeah, we'll just quickly try as much as possible to not make this as boring as it's usually gets. So cloud computing is actually, everywhere now. I think before I even start, going through all of this, uh, it's kind of hard to actually pinpoint but I'm just going to say is delivery of services over the internet, that, like you guys have said, by a cloud provider, but it goes beyond just cloud providers now, as we'll see very, very soon. So YouTube is an example of a cloud computing based product. So our phones, our laptops cannot store all of the videos that we can watch on YouTube, and even in memory. It would, even if you have a 1 gig storage at some point, if you keep um, putting different videos in it, it would fill up very, very soon. But with YouTube now, YouTube has all of the resources to store all of those videos in, they have the resources, to store all of those videos. So all we do from our phones, on our laptops, is just stream. We'll request, access to those videos, and then we can stream them. So the cloud, again, is not, that's like a very, very, an example of what cloud computing, one of the products that cloud computing actually makes possible. Yeah, so organizations actually store a lot of data. They have need for analytics now in the world of machine learning and AI. So many data that needs to be tapped into. So the cloud has kind of revolutionized how data is being stored, accessed, and processed. It offers the technology to actually do it. So whatever one's use case, if you need different computing, resources, if you need, depending on an organization's use case, you need servers now to house your applications, or you need storage to store all of the data that is being generated. And even if you need databases to use to, again, still store personal information and information that the business actually uses or generates. So all of these things has in a way been made into services, resources, that can be accessed using the internet. So instead of organizations, maintaining their own data centers now, cloud providers are taking advantage, or they've taken advantage of the economy of scales. They've invested so much into owning fleet of data centers that, organizations that can now kind of come and take advantage of, aside just the physical infrastructure now. We have various softwares, resources now that has been incorporated, things that ordinarily, if you've ever worked in a data center, I have, and it was a very interesting experience. Say you just want to set up a storage file system now, all of the things that you need to configure to get that up and running for users to, different users to take advantage of. So, the cloud providers, they have, taken that role of maintaining or providing all of these different services, on a very, very large scale. So all organizations or individuals now, and then they've opened it up to everybody. It's public. Yeah, it's very, very flexible. I, as an individual, if I need whatever the size of infrastructure that I need, I can, go there, take advantage of it, provision it, and if I need to, scale as much as I want, that flexibility has been handed over to everybody, not just even organizations now. Excuse me. Yeah, but we are looking at this from the enterprise level. Yeah, for organizations to actually set up their own infrastructure, their own storage, and or what have you. It would owning our infrastructure requires you to purchase, configure, and then maintain those servers, that run the different services that organizations use now. So through managing infrastructure requires a lot of work and, expenses also. So organizations now, so provisioning the right kind of infrastructure can actually, it will require a lot of work. And so for an organization now, this, kind of that just developed a new application, and then they don't know the amount of customers that will flood their products. Yeah, so instead of creating or provisioning for a massive amount of infrastructure, with the hopes that they would have the customer base, and then when the customers don't come, they've already invested so much on infrastructure, and but the cloud actually solves all of this issue, slashes the time, the cost, and effort required to maintain all of these computing services. Yeah, well, the cloud providers, they offer enough power at so we can configure servers in milliseconds. It's that fast. Yeah, and the servers can scale depending on the need of a business or an individual. Yeah. Did I see somebody's hands up? So cloud providers, again, like I said, they have data centers and they host locations in all over the world. There are some. I am distracted by. Okay, so there are advantages to using the cloud. We have cost savings there, security. So users can access cloud application and data from anywhere with just your internet connection. All of the underlying infrastructure, the maintenance, and the management is handled by the cloud providers. And so organizations can actually focus on core business objectives instead of managing IT operations. Yeah. So if you've ever worked in IT operations, you know that is a lot of work. So cloud computing has become very, very essential for modern enterprises, especially those that want to take advantage of, they want to build and innovate very, very quick. The ability to quickly test out, okay, yes, for this product, we want to see if it's going to be even feasible to develop instead of having to, wait for weeks and for the IT operations guys to, get the servers up and running. The fact that you can spin up, servers in very, very milliseconds, very, very fast there. And then the developers can immediately start work from the point of the inception of that or conceiving of that idea to time to when the product is up, very, very short time. And then we can actually have highly available and fault-tolerant infrastructure that would help us have, we'll save so much costs, moving to the cloud. The cloud has made all of these things available. Yeah. So again, some of the benefits of the cloud, organization can manage their technology infrastructure and operations very, very easy, from the console there. Businesses can unlock a wealth of transformative benefits, instead of having to reinvent so many things. You can just take advantage of all of the services that are available. So one of the primary advantage is the flexibility and scalability that the cloud offers. I can't overemphasize this. You can scale computing resources up and down, to meet changing demands. If you have, say, a product now that's, maybe during the day, you have your customers flood that product, and then you need a very, very large, resource. You need large resources to be able to cater for that deluge of requests coming in. Yeah, you can easily scale out, and then because you are paying, there are different pricing models now. We'll talk about this in a bit, where you only pay for what you use, and with that, it becomes very, very interesting. Yeah, you don't have to worry about over provisioning infrastructure or not having, the right capacity to meet changing needs, without the need for, costly on-premise, investment, total cost of ownership, and all of that. So organizations can quickly adapt and then, again, key into new opportunities, give organizations the ability to explore different services without having to worry about spending so much on infrastructure. So another key benefit is, again, cost saving. All of the capital expenditure that is associated with owning and maintaining your own servers and storages, the cloud services, abstract that away from you. And then again, that's pay as you go pricing model makes things very, very flexible. Yeah. So when you don't have a predictable kind of know-how on what your infrastructural needs are, cloud helps you to, save on operational costs, and then, again, they take advantage of the economies of scale to achieve this, feats. Yeah. So there is improved security, data resilience. So the cloud providers, they provide, they spend so much on security, securing their data centers and what have you. So the locations to data centers are actually, would I say, secrets? Yeah. So instead, so as an organization, if you have a building, so you want your building to be as open, well, to be in places where everybody can see, and this opens up your organization to all sorts of security risk and what have you. But again, all of this has been abstracted away. And then the cloud providers, again, wherever it is, they want to keep their data centers. They've invested so much in, advanced security measures, including encryption, access control, very robust disaster recovery protocols. There's some services that you run in the cloud that the cloud provider out of the box, they kind of help you replicate, whatever it is, your services, your data that is being stored. They replicate it in different locations so that anything can happen to a data center now. Yeah. So in case of disaster, you still have access to your data, your information, which as an organization, you only have one data center, except you want to decide to, have different data centers, and then you spend more. Yeah, but all of these things come out of the box depending on the service that you're running in the cloud. And then if you need data compliance and protection, yeah, cloud providers also offer all of this thing. Yeah. So if you need to back up and restore seamlessly, while mitigating against data loss. Yeah, all of these things have been embedded into cloud computing. They've been made available. Yeah, so the power of and the benefits of cloud computing is so much. Nope. What's this? I have scattered my.
To me, I would say security is one of like the major, and availability.
Yes,
security, availability, and reliability is one of the major concepts about cloud computing, because the cost of having that easy reliability and security level that comes with cloud computing. I've been able to manage a server before. So, and I know one time that we had to do like an application getting a sonic wall. The sonic wall you have to get to order to set up, like when you want to set up a server and all of that for purpose of security. The cost of even getting it down to Nigeria after that year, and the process and the demand you have to go through, filling the form, doing all of this stuff with customs and all, is just so stressful.
It takes weeks before you get all of this infrastructure, up and running.
Yeah.
Yes, it's a lot. Yeah. So, Taiwo, your hands are raised.
Yeah, I want to ask, is it possible to set up always on the cloud?
To set up?
Always on.
What do you mean by horizon?
I don't know, maybe you're familiar with SQL Server, Windows, SQL Server, Microsoft or not.
Yeah.
Yeah, I don't know. Maybe you know about always on high availability, other stuff. Is it possible?
Yeah. So if it's a database feature, everything, whatever it is you can set up, on your on a PC, you probably have a
On,
service.
on premise.
As long as you can do it on prem, you can,
Yeah.
if depending on your use case, you can do it in the cloud. The cloud makes it, and you probably, as we'll talk about soon, you have probably an out of the box service that would abstract having you. So say you want to set up a database now, there are different ways in which you can actually do it. You can decide to set it up yourself, and then there are services that already have set up the database for you. All you need to do is bring in your data into it. So we have this different. We'll talk about that in a bit. Yeah. So
So I think this question was the high availability. I think the cloud, I think it gives you more opportunity for that. But one thing I know about the cloud, one of the major factor about cloud computing that especially we in Africa do not have not really much embraced it, much administration is cost.
yes.
Cloud gives us more flexibility over the physical data center. But from my little experience, anything we can do on the on-premises data center can be done seamlessly on the cloud. In fact, it is even more easier. It's even more easier to get them done on the cloud than getting them done on your physical infrastructure. So it's all about click, 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 and click. And so I think the cloud gives us that flexibility more than the on-premises infrastructure. Just the cost. If you are talking about high availability, active, I think that is what you mean. Active.
Yeah.
Your organization needs to have. I think the rabbi should be ready.
So even if you want to set up your own architecture to be highly available, it means you will be purchasing double of the infrastructure that you would have gotten ordinarily. And then you probably need, if you want to, again, consider disaster recovery into your high ability, you need to set up in multiple locations now. So the cost of all of this, on the long run, if organizations wait, they'll see that they spend less in the cloud, having to have this in the cloud compared to, taking to
I don't think they spend less in the cloud though, especially with the rising with exchange rates.
Yes, exchange rate.
I don't think they don't spend less in the cloud.
No,
like I said earlier, I think that is the major factor with organizations especially Nigeria.
Yes.
That is one of the major factors.
So I was taxed
because when you look at the cost, cloud is not cheap. Let's not even tell ourselves. Let's not even deceive ourselves. Cloud is not cheap.
Having owning your own infrastructure is not cheap too.
Can I add something?
Okay, Henry.
So what I would like to add is, first of all, to answer Taiwo's question about always on, is definitely possible in the cloud. Whatever you can do in your on-premise environment or your on-premise data center, you can definitely achieve it in the cloud. It's just being able to set up your cluster, your high availability cluster, and make sure that all your servers are ready, and then you figure out how your configuration would be. But basically, the answer is yes to that question. I believe so. Have I implemented it before? No, I've not. But I've heard people talk about it, and I know it's very possible in the cloud. But when it comes to the cost, like you're saying, if you own your own data center on premise, because even the cloud is also a data center somewhere, just being managed by somebody else. right? It's not literally in the cloud, like in the heavens, right? It's someone else. It's someone else's data center. The person is just the person is just taking away all the admin overhead away from you. You don't have to do any you don't have to have people to manage that whole data center for you, right? So if you own your own data center and you have you definitely will be paying administrators to manage those servers, right? To ensure that those servers are up and running.
Always.
And you exactly. So you definitely have to pay those people for that service.
You pay for
Exactly. Exactly. You pay for
security as well too.
Yes, exactly.
Exactly. So if you take all that cost put together and you just package it in one, you will see that if you're saving money, it's not going to be very significant. Plus, you still have the headache on you, right? With having your infrastructure in the cloud, you have someone else to blame for your problems, basically.
Yes.
Right. And that's what a lot of people don't say, but it's just the truth. If something goes wrong, like for instance, Microsoft guarantees like 99.9 to the power of 4.
SLA, very, very high.
Yeah, exactly. The SLA is very high. So if anything goes wrong within, I mean, it won't even take them
switch
2 hours, depending on exactly, to switch to another whatever region, whatever, and to give you your uptime. So their uptime guarantee is almost 100%, 99.9999. That's really, really high. Now, if it was you managing that thing yourself, if your IT admin gets hit by boss, just know that your customers are crying.
Everything
a lot of high blood pressure.
Exactly. So it's so many things that you cannot just like. I mean, the cloud might be expensive, but if you really look at it from a business perspective, it's like buying a very reliable car for 20 million, or going to buy a car for 7 million naira thinking that it's cheap. You will spend the rest of your life in the mechanic workshop.
Yeah, exactly. But I know what from Bliss's point of view, he's saying, so for organizations that actually earn in, say, naira now, and then you're trying to maintain a cloud infrastructure that you have to pay for in dollar, the cost of the exchange rates take a toll on the organization. So if you're looking at from that angle, it will be probably expensive.
Even on that hand,
availability in the cloud self comes with its own cost. This cloud architecture, those guys are money oriented.
Yes.
This cloud service provider.
Are there no local CSPs in Nigeria? Are there no cloud service providers in Nigeria? Local
ones?
There are
affiliated. Lots of them in Nigeria.
There are Airtel, they all have.
There is this company that offers internet. I know them very well. I was even applying for them. Applying for a role there one time. Like, I'm trying to remember their name. They offer like fiber. Main one.
Okay. But
I applied lots of time.
Their infrastructure is,
they have one in the
using Azure as their underlining provider. So the cost of even running a data center in Nigeria is they will frustrate so much out of you.
Yeah, it's true. Because even the cost of getting experienced engineers to manage your data center or to manage your server rooms, and to even the cost of diesel and all. Because I remember at the time at which diesel price skyrocketed, that was at about 2022. I was still managing a server, being in charge of I was the server administrator. I know how I was being called into a conference room by the CEO, the directors of the company, being given like a kind of like an advice on how to cut costs. But the true thing is that there's no way you can cut costs, because the server has to keep on running, and they have to pay for diesels and the rest.
Yeah.
Because diesel for the month, which was around about 700,000, was going to about 2.9 million naira. Just imagine, just to keep 2 server rooms, the DRO server rooms and the main server rooms running. So which the company, they weren't really like, they were trying to cut costs at every means, because most people were running away from business and all of that stuff. But the truth is, the best way to save money is actually to move to the cloud. As an IT person, I give them this advice, of which when they made inquiry into getting a service provider like that of Min1, the bill Min1 gave to actually move the servers after doing the whole analysis and all of that stuff was very, very outrageous. It was up to about, I think, 5 point something million, and there's no cost of maintenance for the year already.
Okay, so let me ask you this out of curiosity, right? So when Min1 gave them that, when Min1 gave them that bill, was that a one-time bill, or that was going to be like a recurrent revenue for Min1?
No, that's not like a one-time bill. The one-time bill is to move like when you're moving, it's like migration. Like when you're migrating from on-premise to, it was the migration, the cost of the migration. Then after which you now have to start like paying for your services, like for your on-time services on the cloud, on their own environment. So which they just felt that was really, really outrageous. But to me, I feel like that was the best thing they could have done.
Yeah.
Because after a few months, they lost a whole loads of files after the server crashed because they kept on turning on the generator when you are using like all these 4 kVA generators. the server died because the servers are not meant to be turn off or turn on like uninterruptedly like that. They lost data, so we had to it gave the IT team like a loads of stress because we had to start like retrieving files from the DRO servers, like back and forth, doing setting up read all over again. So it's like load of work, but at the same time, there's nothing like in IT. IT always give room for like improvement, like always moving ahead with the current trend of IT, which is the cloud, the availability, easy access, the security, the up to date, and all of those stuff. So that's just the best way to go.
So recently, somebody shared an article with me. I can't remember the name of the organization now. It's a Fortune 500 organization. So their CTO was the one that wrote that article. So he weighed what they spend, their cloud spend, yearly, and then he did like a projection, say another 5 years. If they take that amount and set up their own data center, it would even save them so much money. And maybe for some organizations, running their workload in the cloud may be very, very expensive, but this does not still take away the fact that flexibility that the cloud offers. If we just keep looking at it from, say, the cost standpoint now, we're just going to be here because it varies from organization to organization. But overall, I think the cloud is a fresh breath of air, to so many organizations in terms of management, and then the ability to innovate, very, very fast, with very, it's not cheap, but compared to having to own it all. So the cloud is here to stay, and cloud-centric organizations actually innovate faster than those that want to stick to their old ways. So we have different deployment models. So this, again, is still kind of classifying all of the things we've been talking about. We have options to choose from depending on what the organization's overall goal is. We have 3 is very, very popular. The community cloud is not so very much popular. So again, all of these things, the reason, the purpose of introducing us to these things is so we can understand what to use, when to use it, or when you find yourself, in settings. Again, you will be interfacing with quite a number of stakeholders, and then your ability to paint the clear picture of what you want the organization to use and how to use it would come in very, very handy. So all of these things are not knowledge that would be lost. So we have the public cloud, which we have been discussing, is like the the art of this module. So this is the most common model now, where cloud resources are owned and operated by a third-party provider, AWS, Azure, Google. This offers flexibility and probably zero upfront, cost if depending on the service you want to run. Then if you want to dedicate a few resources, you would probably have some upfront cost, which is still would not be as expensive as totally owning that infrastructure. And then the pay-as-you-go pricing model makes it very, very attractive, yeah, for startups and small and medium businesses. And most of them, they offer like an interface. Sorry, please excuse me. So they have millions of customers. The public cloud, again, public, they offer huge variety of cloud-based services for customers to use. Again, applicable to any kind of business, not just startups or small and medium businesses now. Even already established Fortune 500 organizations can take advantage of public cloud. Again, some of the benefits, you pay per usage model, as pay as you go model, which means you only pay for what you use. The ability to handle large amounts of traffic across many customers if you set up your infrastructure right, and design for high availability, very, very not easy though, because architectures can get really complex, but you can do this seamlessly. Yeah, you can try out things as you want. You don't have to worry about the hardware having to get all of those things. So there's a few challenges, obviously, is especially if you're limited, if you have just one, if your organization say a startup now, and then you only set up one, you'll be limited by what the cloud provider offers, which again is probably more than what your organization needs now. So this I don't think is a and then I don't know if this is a challenge. Why do I even want to worry about direct access to the hardware? But the fact that you don't have direct access to the hardware can be a challenge. And then in the age of information security, data security, organizations have to trust the provider with all of their data, yeah, and what have you. So for organizations that are seeking control over their infrastructure, the private cloud is the kind of deployment model they probably want to stick to. So again, it's still a kind of dedicated cloud infrastructure. I think I mentioned organizations that want control. They have control over, a dedicated kind of infrastructure.
Hardware, yeah.
Hardware, yes. They don't want to share with any other. They don't want that tenancy to be shared. So this again just helps you kind of customize and then have security over your services. Again, this would require that you're going to obviously you don't want to stay in, say, block of flats now. You want a mini estate to yourself. It means you're going to pay more. It can actually be owned by the customer, say data centers the organization own now, they decide to own everything, or they can have a third party cloud provider and own part of that setup now. So no other customer works within the same machine, that organization owns. Say in AWS now, just buy out a rack inside a data center, some in one of their regions. Yeah. So and then this means that any service now that is that needs to run inside of that set of hardware now, it is the organization now that would have to set up all of those things. Yeah. Very few organizations I think would want to manage this. I think mostly government organizations and maybe some financial institutions and some medical organizations are the ones, again, because of the kind of sensitive information data that is going to be managed, as part of the setup. Yeah. Again, the benefit is just that they have increased control over the infrastructure. Yeah. And this mostly as organizations have to comply with regulations are the ones that probably want to go this route. Yeah. And then can customize all of that infrastructure as you want. For hybrid cloud, this is a mix, a combination of both public and private clouds, allowing organizations to leverage the benefit of both. Again, this gives some form of flexibility, and then around an organization's workload. You both spend less, and then for the public cloud and then for the private one. So it gives that kind of flexibility. So for workloads that have compliance and regulatory needs, those can sit in the private section of that infrastructure, and then other public services can sit in the public cloud. So and this is actually yeah, hybrid again is just a combination of, it doesn't have to be public and private. You can have two public cloud providers. Okay, that's on another level anyways. So this community cloud is not very, very popular. Is just a group of organizations now that want to share the ownership of infrastructure. So a shared cloud infrastructure used by multiple organizations with common needs, mostly around compliance requirements. And then they can benefit from the economies of scale. They, bring in their resources, and then they set up a cloud infrastructure, and then this would, the save cost on having to both since they have common needs, some of their needs would intertwine, but this would still mean that, especially if they are very particular, organizations, privacy varies across different organizations. Yeah. So yeah, they would have to set up group of people that would have access to the cloud, and these are the people that would customize it. Yeah. In fact, that you can divide management work and then the costs between the organization, with securing the infrastructure and all of those management things. Yeah. Yeah, so there is a third one, that's multi-cloud. That's where you can use multiple public cloud providers. So that is not part of the slide, but we have hybrid multi-cloud. Yeah, just basically combine different, you mix and match all of these different deployment models. I see that we have used, can we take a few minutes, 10 minutes now, and then we'll be back in in 10 minutes. And then we'll move on from there. No feedback.
Yeah, that's fine.
Sure, that's fine.
All right. I'll be back in 10 minutes. Welcome, welcome.
Thank you.
So we'll be moving on now to another heartbeat of the cloud. These are called there are different types of cloud services. Why I don't do this? Okay. The different we have as different businesses are moving into the cloud, it can be kind of challenging to distinguish between different cloud providers and what they offer. And then the cloud providers, they have, in a way now, they have made it possible to made it easy, yeah, to kind of bring their services together. Yeah, so there are the different service models. Yeah, we have deployment models and service models. Yeah, so I wanted to simplify by saying types of cloud services. So there are cloud service offerings. Yeah. So we have so many of this now. It's termed service now. So, but to assist with knowing how these different services, how they are grouped, or depending on an organization's workload now, or their use case, their need. Yeah, these different cloud providers, they offer services that make this move and switch kind of more flexible. Again, in short, they are the different service models. We'll be picking three out of because right now we have quite a number of these service models, and in a way, this kind of describes the shared is hinged around the shared responsibility model that describes responsibility of both the customer, the cloud provider's customer now, and the responsibility of the cloud. Yeah, and and then these different services are hinged around this model, this shared responsibility model. So we'll be picking just three of those models that are quite popular now. The infrastructure as a service is like the fundamental cloud computing service model now. Again, it provides organizations with the on-demand access to essential resources. Yeah. So I have a picture of, let's see if I can get that. Sure. I'll just bring that up. This would, in a way, before we start talking about each of them now, let me exit from the full screen here. And let me bring up this. So this kind of depicts what we are about to talk about in a few minutes now: the infrastructure as a service, the platform as a service, and the software as a service service model that we want to briefly touch on. The blue parts are the responsibility responsibility of the customer now, for the infrastructure as a service, even though the cloud provider is responsible for maintaining the physical hardware and its access to the internet, and then the security, of all of that physical infrastructure. But when it comes to installation, configuration, patching, and then securing your data inside of any of those service. So that's kind of model is this. And then, so as this is like a picture of what we are about to discuss, and then all of the different services, they are kind of categorized depending on the service. Yeah, again, like I said, there are other X as a service. We have function as a service now. We have, I think even AI as a service, machine learning as a service, all of that, use case, they have kind of been categorized now. But would just on this is like the foundational ones here. So we'll look at these three in details in a minute. So let's present this. For the infrastructure as a service, like I said, is where an organization is like when an organization wants kind of more control over the infrastructure that they are maintaining in the cloud. Yeah, so it offers that kind of flexibility. You can easily scale out your computing, as you need. You have some form of control over the service that you're running in the cloud now. So you don't want to, the organization does not want to worry about, all of that high capital expenditure, associated with the traditional on-premise infrastructure, but they still want some form of control over, the IT resources. All they want to do is have a provision infrastructure, and then they manage that infrastructure. Yeah. So yeah. All right. So okay, yes. These infrastructures again, for every of the different service model, they are managed either through the console or through APIs. The only difference is that the customers do not have direct physical access to the hardware, but there's more control over it compared to the PaaS or the SaaS offering. So basically, customers virtually administer the infrastructure. That's the highlight of this. Yeah, you can customize your services as much as you want. And then, yeah, the pay-as-you-go cost model still applies to this. But yeah, the fact that you would have to configure and then manage all of the services again you'd need some form of expertise, in terms of the service. You need to, yeah, probably train, the organization will probably need to train if, well, they don't have, already trained people to do the administration. So popular infrastructure as as a service offerings include for AWS, the EC2 instance is a popular infrastructure as a service. So with that, whatever your organization needs, if you want to install a database in there, you can do that. If you want to even have your Active Directory, inside of an EC2 instance, and whatever custom application, you can have those. So all you need to is you just manage the virtual machine, the storage, and then even the networking. And then anything you want to put inside of that virtual machine is up to the organization. Again, more hands-on. It's more hands-on. Yeah, this is not moving. No, I don't want to edit. Right. The next model is the platform as a service. This is more, it simplifies the creation of is more developer centric kind of, I usually say, but not really. So when you it's in a way guides users when you need to deploy application very quickly without having to worry about the underlying infrastructure. You just want to bring in either your code, your database, or your application now, inside, or you want to deploy it much faster without having to worry about provisioning, setting up, installing dependencies and what have you. So that's why I said it's more developer centric. Most developers find this easy to use. It helps to quickly deploy applications without having to manage, understand even, all of the underlying infrastructure. So the cloud providers, they have services like that where they handle the provisioning of the hardware, the installation of softwares, and all of the different dependencies depending on what you want to do. So developers just focus solely on the application development and writing of their code. Yeah. So again, the key advantage is that streamlines the application lifecycle. Yeah. All of the planning for the instance type and all of those things, you don't have to worry about that. There are some PaaS offering that even helps you pre-configure your libraries or framework or whatever that you need to do. And then updating them even as you go. So again, this reduces the time and the effort required to set up and maintain all of the development and even production environments. Again, offering in productivity and then agility. So some of the PaaS offerings now. So in AWS, there are a few of them. RDS is one of them. So I usually call them managed services. They abstract quite a lot, from you. All you need to do is point to your code base. If your code is sitting in a remote repository somewhere, all you need to do is just authenticate with on AWS, and then AWS will handle all of the provisioning. Yeah, so even Google App Engine and Microsoft, the Azure, they all offer different PaaS services. Yeah, and simplifies deploying application so much. Yeah, but I think before moving to using for a cloud professional, you first want to know how to manage, the infrastructure as a service offerings, and then by the time you now switch to a platform as a service offering, you kind of appreciate that knowledge. Yeah. So past offerings from experience, I know they are reliable to a certain degree, but it comes with its downside. You have limited customization if you are deploying an application now that requires some very some tools now that probably all of these pass offerings they don't offer. You probably would need to maybe you may not be able to customize the pass offering. Yeah, so it means you have to use an infrastructure as code service. And then most of these pass offerings, they are usually cloud, provider kind of centric. So once you use them, you can't move from one cloud provider between different platforms, basically. We'll see all of these things when we start using them, some of the downsides to using all of this. Right. And software as a service is been around, is emerging. Yeah. Again, this just tells about how application softwares now are being accessed. The organizations don't have to worry about all you need to do is it's just software that is available over the internet. I think that's like the gist of software as a service. So organizations make use of their customer relationship management softwares now that have been, pre-built that organizations can take advantage of. We have, ERP systems, even HR management systems now that are, yes, exactly. You just, sign up and then you use. Yeah, so we have so many softwares moving to this kind of deployment model. Just yesterday, I was put into a call, and because we offer a SaaS ERP system, and so the cost of deploying for the application was not well architected, and I keep saying this. So for every user now, that application of that ERP system, it has to be installed on a new instance. So, the call was about how we can, in a way, start deploying it on having to move, deploy on customers' own infrastructure instead of having to host in the cloud. There are so many back and forths, at that. So, but or we now want to move from a SaaS model, to now putting responsibility on the customer. There's so many downsides to, doing this, but, organizations while some are trying to move into streamlining and making their softwares, much easier to access. Some are moving out of it. Again, depending on the kind of software, things can go anyway. So again, some of these SaaS as a software products are probably used well for the cloud ones. It's organizations that take advantage of this. Organization just subscribe to, say, a service, a tool now that they use. they are basically cloud hosted applications, yeah, that provide user with instant access. Again, like Adford said, is you sign up for it and you use without having to worry about, even the code that makes it tick. Yeah, just consuming is a consumption kind of model. And so when we think about even our email provider now is a software as a service, storage providers, now Office 365, Google Workspace that contains all of the Google Docs and Google and all of those softwares that are offered by different providers. Again, don't have to worry about so many things as a user. Yeah. All right. Moving on. I'm sure all of these deployment models. Or are there any questions around it? I want to leave not. Okay. For the cloud providers, I'm sure we are all familiar with this top three. The number of cloud providers that there is the list is, it keeps growing, day by day. We have tons of them now. So, and they spend quite a lot of money trying to convince us to use their different platforms here. Well, which one should we use is, I think, that being a more valid question. While all of these cloud providers have a lot of things in common, and I keep saying they all have the same underlying principles. By the time you have used different ones of them, you see that it's just probably what they call their different services that differ. Yeah, the services are the same on the underneath, but each of them they still have their strengths and their weaknesses. That might make it more or less suitable for depending on the use case now. Yeah, but we're just going to focus on this, on the top three. AWS is still the market leader. They offer quite a number of services and solutions, yeah, depending on your organizational need. In fact, they are integrating with different third-party tools now, so that if your organization already has, say, an ongoing relationship with a tooling company, there are solutions in AWS where you can bring in, integrate, that tool into AWS, and so that you can have one place of managing all of the suite of tools that you have. Yeah. So even so Microsoft actually are like the pioneer for Active Directory, but AWS now has a service that allows you even bring in your Active Directory forest and what have you inside of AWS and manage it inside of it. So for organizations that are have Active Directories with all of their users in there, and then they are thinking, how are we going to now we want to migrate to the cloud? Should we stick to Microsoft, or should we take advantage of AWS because they have more services? So all of this, AWS is trying to kind of dominate so that you don't think about the other two. Yeah. Again, I think they still are the go-to platform for both enterprise and startup alike, because of how reliable, again, they are. And then some of their services, like we talked about earlier, out of the box offers you SLAs that are close to perfect, 99.9999, because they take your data and then they store it in multiple locations so that if anything happens
AWS or Azure?
Yeah, AWS now. AWS. Yeah, even most Azure, GCP, all of them, they actually offer SLAs that are very, very high, depending again on the service that you're using. So Azure is also coming up very, very fast. I think for organizations that already have invested in the Microsoft ecosystem, Microsoft had been around for a while, so offering enterprise solutions to most organizations. So if your organization had already invested so much in, I mentioned Active Directory, now you use Active Directory to manage all of your systems and users and what have you, it would be much easier to move your workload to Azure. They have services that make it very, very easy to move your already established database, Microsoft SQL database to Azure, with just a click of a button and all of those things. Yeah? And then yeah, so they also offer quite a number of, services. I have been a Microsoft fan for a very long time. And so while I was learning in AWS, I was also, learning Azure. And then it was actually easy because I was now comparing their different services. Whatever service I use in AWS, I try to also if I do anything in AWS now, I try to do the same thing in Azure. And so this actually, you see that is, yeah, they all have the same set of tooling. It's just called something different. And then I think it would also be a good skill if you are cloud agnostic. And it is this knowledge that would actually give you that kind of I don't say power now, where whatever organization you find yourself, or you are privileged to say you want to consult with, and then they already have say a cloud provider they're using. So your moving or using able to administer that cloud provider, the learning curve will not be as steep as because you understand that okay, it's just a matter of knowing what this service is called in this cloud provider, and then but the knowledge of one of these I can use to administer this. So if you know how to use AWS properly and you know all of the services that you can use them, moving to Azure would be very, very seamless, or moving to GCP be very, very seamless, or whatever cloud platform. Yeah, it's just probably the interface now that will be different. Yeah, so Azure again is owned by Microsoft. Then GCP, Google Cloud Platform is I want to say this. I know this is being recorded, but I don't find this cloud provider very, very um, easy to work with. I know people that are crazy about them, but I tried using and nah. Even though they have their pricing structure is, I think that's their strong suit. It's not compared to AWS and Microsoft Azure. Their pricing is not very steep like that. Yeah. They I think they tend to be the least expensive option out of the top three now. And if I mentioned earlier that which of these ones would you want to use? So for GCP, I think if your use case is around big data and machine learning, yeah, I think they actually thrive in that part of cloud offering. Yeah, so even though they have fewer services compared to AWS, and then the SLAs are not very, very, because they have very few um, global data centers. Yeah, but it doesn't mean that they can't, they are growing still very, very fast. Yeah. of you. Like I said, we have those are just the top three. There are many other cloud providers with their own specialization and then strengths and weaknesses. Yeah, we have the Red Hat Cloud services. Red Hat. When you hear Red Hat, you want to think about Linux. So if your workload is centered around, say, Linux administration and then the focus on security, Red Hat Cloud Service, they also offer other services also. Again, like all of these cloud providers, they are reinventing themselves. When I started using DigitalOcean now, they had very few, probably, I think it was just their database and then their droplet. And now they have tons of every day they keep sending different mails. We are introducing this, introducing that. So the competition is actually growing very, very fast. Yeah. There's the Oracle Cloud, Alibaba Cloud. Yeah. So much of them, yeah, and you probably would not have to even use all of this. Even Terraform now, I think HashiCorp Cloud is also there now. I can't even say I can't boast of having to use all of this, but probably have accounts there, but I've not had any reason to say I want to use all of them. But this top three, I've played around with them: DigitalOcean, Oracle, yeah, a few of them. Again, it's once you understand that they all offer resources or the services in the cloud, that would save you worrying about. All you need to do is just get familiar with probably if you are the API consuming one, you get familiar with their how to call their services using the API, and then they all have GUIs that you can interact with. That's the beauty again of it. So would quickly run through some careers in cloud. Like I said, it's always good to know the options that you have so that you know, depending on your strengths, where you want to tend toward. I know this is a DevOps bootcamp, and as we'll see very, very soon, that I didn't even list DevOps as part of careers in the cloud because again, I think DevOps is a mindset, is a way of, it's more of a cultural shift. Yeah, I have mentors. I have mentors that are so vehement when you say you're a DevOps engineer. It's not a role. Stop calling yourself a DevOps engineer. Yeah, I do DevOps. Like, okay, that's better. Yeah. So again, the cloud computing industry offers a wealth of exciting and lucrative career opportunities. I think most of people moving to the cloud now, yeah, it's because of that second part. It's the money that is attracting most of us. Yeah. Okay, I see there's a message. So you guys can always unmute and talk, except you're in a noisy place. I know that's fine. Based on your experience, which of these services, compute, storage, DB network, are we going to work with? Everything, everything. So again, this is maybe hinged around your the organizational structure. But as a DevOps practitioner, you will have to know, you'll be using quite a number of services here. I don't know if I've mentioned it if in this class. I write queries like with my screen being shared. You would probably be managing depending on your level. You'll be the custodian of both database, the storage, different storages, and even the networking of so this varies from organization to organization. So you must have, experience with all of the services and how to use them. because they'll just expect that you know so much. You have all of the cloud knowledge. You have cloud being tended towards the operation side, and then you have a little bit of development knowledge. So if anything breaks, you are the first point of call. If anything, even if developers they cook beans now, they forget to close a query, and it doesn't run, they'll come to you. Say, your my push is not showing. It's not showing on the like. How am I supposed to do about this? But so when we look at some of these carriers in the cloud, you'll be able to now see what service or what role um, individuals are supposed to play. But again, and I keep saying, for the most part, you would be wearing multiple of these hats. Yeah, as a DevOps engineer, yeah, you would be combining solutions architecting to engineering, cloud engineering roles, and what have you. So we'll just be exploring some of this cloud computing career. So once you find yourself learning the cloud computing, it opens you up to, a world of possibilities. Yeah. Some of the skill sets now that you need to have there are some of the things we'll quickly look at, in the few minutes that we have left here. And yeah, some of this you see that they have kind of similar skill sets, that you'll be using. And then their responsibilities kind of intertwined. So let's quickly look at some of this. I keep putting this thing on spotlight. So the cloud architect is the first one we're going to look at. As a cloud architect, usually you'll be responsible for, I put usually, for designing and then maybe overseeing the implementation of, because when you design something, you want to make sure that, they build to specification. So you'll be coming with architectures now. Yeah, so that organizations you would meet with different stakeholders. They tell you, okay, yes, this is what we want to achieve. We want our application to not be accessible by everybody. We just want it as an internal application that our marketing team can use, and this is what we want to build. Okay, then you are able to, come up with an architecture. Okay, yes, we can put this in a private subnet, and depending on the kind of application that needs to be built, the different services, that would be used, in combination to get the application up, and then you come up with a diagram, and infrastructure diagram, architectural diagram now. And then this will probably be handed over to some other roles. That is, if you're not the one that has to both design and then implement it. Yeah. And this means you need to have very deep understanding of different cloud technologies. So you would I recently just trained somebody that was supposed to prepare for, well, we prepared together, I would say, a solutions architect professional certification. And for that professional certification, that's professional, parts, you need to we covered 150 AWS services. At a point, I think my head was removing smoke. Yeah. So your ability to sit in a room and then come up with use case, use of different, and would see when we jump into architectural diagram, because one of the things I would want you guys to take away from this module again is to see an architectural diagram and then even come up with your own architectural diagram aside seeing and then be able to interpret it. It's always good to have that, ability. So that's what basically the cloud architect does. You must be versed in a variety of cloud, platforms. Again, you must be cloud agnostic. Depending on where you find yourself, the suite of services that are available in the different, cloud providers. This would come with experience. I want to say practice, but practicing in different cloud platforms will probably is something you would gain experience on as you work probably with different organizations, and then you have to help them come up with architectural diagrams for different solutions. Yeah. Yeah. So basically having that knowledge of all the different cloud services and how you can bring all of those services to work together, from not just the technical standpoints, you must also be able to communicate. I think all of these rules now will be seen in the cloud because you would be interfacing with, as you explain, as you come up with your solution, you need to get, the different stakeholders to understand, the benefits of using one service, over maybe a service that they are familiar with, especially when you are doing some migrating or re-architecting. Yeah, you would need to be able to explain all of these services. And it means I must understand the services, even if you don't know how to provision them, or because you'll be working alongside again cloud engineers in doing this. All right. So, and like I said, after the cloud solutions architect has come up with, the architectural diagram gets handed over with to the cloud engineer. So the cloud engineer is more hands-on when it comes to, provisioning, implementing cloud-based infrastructure. So this still requires knowledge of all of this, of different cloud. Well, if you want to thrive really, the ability to work with different cloud providers, you're able to move from, and then most organizations now run multi-cloud. Yeah, so if you're going to be a cloud engineer, you should be able to help your organization both provision infrastructure in, say, their AWS, infrastructure, and then also in, say, Azure. And yeah, so that's basically what the cloud provider would, the cloud engineer would be doing. And then when things, break, yeah, the cloud engineer is the one that would need to come and troubleshoot and then resolve the issue. Yeah, so cloud engineers must know how to monitor, performance of, the infrastructure that has been provisioned already. It means you will be coming through a lot of logs, and the ability to collaborate. Again, I think this cuts across all of the different, cloud roles. You'll be working with, cross-functional teams, yeah, developers, product managers, and even IT operations, yeah, if your organization has on-prem data centers where you need to even connect with, say, your cloud infrastructure that's been provisioned, you work with those guys and then what have you. We have the cloud developer also. This is still revolved around, I think, cloud engineers and cloud developers. They kind of do the same thing, albeit as a cloud developer, your ability to use some um, DevOps, features now, is embedded into, so aside um, deploying infrastructure and applications to the cloud, you be able to make it continuous. That's what we call continuous integration and continuous deployment. Yeah, so cloud developers, if you call yourself a cloud developer, you have um, development expertise, kind of, and then understand some DevOps practices, because you'll be using it as part of uh, your day-to-day use case. Yeah, you must be proficient in programming, because a developer, working with, even if you're working with developers, you'll probably be doing peer programming with them, making sure that they follow uh, best practices, in their, and then their code is as optimized as possible. And then that's cloud native expertise, comes, is added to the cloud engineering role. And for every of this role, I think continuous learning, because of, the ever revolving, evolving landscape of cloud, the cloud. So every of these roles, you have to be proactive in learning new technologies and tools almost every day. Yeah. Finally, okay, the cloud specialist. Uh, So this security specialist, I think every part of cloud computing now, as long as you are using the cloud, your security is kind of embedded into every um, role of this, every career path now. But the security specialist, they call it, call them their kind of security operations. Yeah, it aims, um, practically aims to prevent the misuse of organizations' cloud infrastructure, in looking at it from the security standpoint. Misuse can range from mistakes, prevent against mistakes, because a little mistake can actually cost an organization, its reputation, and then millions of dollars. Yeah, and to preventing cyber attacks and malicious external users from gaining access to an organization's infrastructure. Yeah, so security specialists, again, they focus on controlling access to different cloud services, and then also overseeing both compliance and regulatory standards. So the knowledge of networking is very, very important. Yeah, cybersecurity now is hot cake. And then all of the data privacies, and then security best practices. Um, security specialists must be well versed in all of these things. And most times it also involves, defining roles for different teams, restricting permissions, uh, be writing a lot of policies now that will restrict, access. You're granting the rights access to, again, anything involved around controlling access to cloud services. Cloud security specialists actually do that. And then again, understanding of different encrypting algorithms. Again, we have other cloud. Again, the number of cloud roles is quite extensive. Recently, I was privileged, well, I say privileged now, to help an organization kind of optimize their costs. And in that experience, I got to speak to a cloud financial engineer. I didn't even know anything like that existed. So they they work on managing and your cloud spend basically. They help you look for ways to improve your cloud processes and then and your services efficiently. There are tools again they've built around financial management or in the cloud. Yeah, very very fast with pricing of the different cloud offering. Yeah, telling you even down to the cent of what each cloud service is priced. I was flabbergasted, like, wow. Yes, I hope you basically you have to be kind of financially inclined, yeah, yeah, and then fast with cost-effective methodologies. See, I did not put DevOps as part of this. I know some of us would be like, nigga, why? Yeah, so the cloud support technician is also, I think, for every support is very, very essential. So the cloud support technician actually is the first point for contact for organization facing issues with their cloud-based infrastructure. And these will probably, again, you'll be working with mostly cloud providers to offer fix to cloud users, and you still the understanding of all of these services work since you are the go-to person. And I think support is I've worked as a support, a support role for even for an industry that I never thought I would ever work in, in a court, having to manage an application there was tough. I learned patience. Yeah. Yeah, even the so-called learned people, they will frustrate your ability. I'll talk less of. So if anybody calls me now, no matter how vehement you are, I'll calm you down. Calm down. Let's talk about this. Yeah. So some of the skills, your communication skill will come in very, very and in here. Out of all of this role, if I don't talk about DevOps, I think you people will not join this class tomorrow. Yeah, DevOps is one of the roles that your exposure to the cloud actually opens you up to, and the fact that we are in a DevOps bootcamp. Yeah, it's just necessary that I talk about it. Yeah. So now DevOps is. I know most DevOps engineers are now moving to. There's another new. It's not new again, anyways. Site reliability. Again, they kind of offer the same, mostly similar. They do. Just that site reliability is now they've taken it, kind of branched out in making in uh, monitoring is they've focused on making sure that just like the name site reliability, your different services, infrastructure they are running, which DevOps also does. Yeah. Again, combining both infrastructure and then development work. Even I think DevOps emphasizes automation, finding ways to improving processes for developing a system. You must have, as a DevOps engineer, deep knowledge of both development processes, the software development lifecycle, and also tools. Tools used by DevOps engineer is quite extensive. Aside the fact that you must be familiar with all of the different whatever cloud provider now that you're using. There are other third-party tools now that you'll be working with, Docker, Kubernetes, version control systems, CI/CD tools, and you'll be building CI/CD pipelines and also monitoring also at the same time. And then making sure that systems are resilient. Yeah. So that's again part of the things that DevOps and site reliability engineer actually does. And in all of this, you see, most of these roles they have intertwined, responsibilities. So it makes it easy in a way, for you to both wear multiple hats in all of this. You can both be a solutions architect and also an engineer, and then even a security expert. Yeah, if the organization is willing to pay that much, you can say, yeah, I can do all of this. There's no point bringing in extra and just give me all of the money. Yeah, and I would make sure that your infrastructure is up to date, and then your cloud ecosystem is as safe and then is as usable as you want. Yeah. So I think that is the end of this presentation. I hope you guys are still with me, or I've bored you guys with all of this talk. Don't worry, after this theoretical part, all we'll be doing is serious hands-on things. For those that can follow as we do in class, it will be nice. Are there any questions around all that we've talked about?
So sorry, sir. I wanted to find out from you. You say you work with somebody who said you shouldn't be calling yourself a DevOps engineer.
I didn't get that.
So I want to find out No, I said because of a discussion with us now.
Yes.
You mentioned the fact that you had a person, someone who you once work with, was saying you shouldn't be calling yourself a DevOps engineer. What was the recommendation that you should call yourself? Is it a cloud engineer or
no?
Is it practitioner?
A DevOps.
Can you hear me?
Yeah. It prefers. It's an individual. Obviously, everybody has their opinions. They are free to their opinion. Yeah, it's a senior. He's an SRE engineer, but he just doesn't like the fact that you say you're a DevOps.
Hello, can you hear me?
Yes, I can hear you, Atford. It's like you can.
Atford, we can hear you.
Maybe he's not getting us in real time. His bandwidth is probably so he prefers practitioner instead of he doesn't even believe DevOps should be a role. Yeah. Again, there are different school of thoughts around that. Yeah. DevOps is here to stay, and then and it's so different organizations practice DevOps in different ways. So what you would learn as a DevOps engineer now, when you get to another organization, in one organization, yeah, all of the flexibility and then freedom that you have, you get to another organization, you don't even have that. All they want you to do is come and be monitoring, this is all the logs that we have, be monitoring. You now be like, because you still be working with different people. So again, it varies from organization to organization. That's why they
You
think
didn't talk about roles in networking, storage, and database.
if we cover all of the so, if we cover all the career paths that is available. But so yeah, I know data when we talk about data engineering, data analysis, you may not fully be entrenched in the cloud because you can have all of those tools, on-prem, and I know most data engineers, they probably have cloud engineers and then DevOps guys that would do all of the provisioning of the infrastructure. All they need to do is maybe work on their transformation on the pipelines now. Yeah. So again, but the number of career paths that's we can't cover all of those, yeah. Yeah. And then most of these also, all the ones that we covered, like I said, they have intertwined roles. So if you say you prefer networking now, as a solutions architect, you must understand networking even very, very well, because you will be coming up with architectural diagrams that probably helps an organization have their own custom, like a virtual network now. Yeah. And then everything that you are doing will be revolved around maybe different, let me use virtual, again, network, and how all of those different services sit inside of the network. And then if you can have multiple, depending on the complexity of what you're trying to design, you can have multiple networks, and they have those networks communicate amongst themselves. Yeah, so all of these things are, they are intertwined. The roles, they come in hand in hand. And if you talk about the database side of things, again, as a cloud engineer, you are going to provision an RDS. You must understand, how to set up, if you want to, depending on the architecture anyways, how to create replicas that would, but even read replicas now, and then you want to monitor the database by setting up backups, both differential and incremental backups, and all of the things that, a database administrator probably should, have understanding in. So as long as you're in the cloud, you would be learning quite a number of things that ordinarily would be out of, you think should not be in your toolbox. Yeah, because you'll be called upon to do and handle so many things. Yeah, so the list what you would do. Yeah, it's both interesting. So I hope you guys are ready to learn a lot. So continuous learning, I keep saying, is one of the calling yourself. Hartford, if you can hear us, I mentioned it already, is a cloud practitioner, DevOps practitioner. An OSPO practitioner. Yeah, cloud practitioner, DevOps practitioner. All right, guys. Let's see. Oh, wow. I think we can actually take a pause on here today, and then tomorrow we're going to jump into
Are we doing practical tomorrow?
That's all we are moving on. We have all of this talk. Even myself, I don't tire.
Honestly, I've slept, I've woken up tomorrow.
Yeah. So
Really,
now
the
we
funny thing
would be
is,
moving. All we'll be doing moving forward is, like I said, so let me bring up our what we're supposed the different services that we're supposed to cover. So I term this cloud computing journey, AWS cloud computing journey. Yeah. We've covered all of this module once a day. Okay, we didn't have not introduced us to AWS. I think we have already been introduced to AWS though from all of this talk. Moving on, all of these different services that we want to talk about. From experience, I've seen that if we just pick a service and talk and try to understand that service to the barest minimum would you would have deep understanding of that knowledge, but how all of these services work hand in hand, you probably will not understand. And I believe uh, is and all of these services, they don't sit in isolation in the real sense. You use them together. So when we'll be working, this would do this from a project standpoint. Yeah. So would say we're trying to deploy an application. Now, it means you, depending on the different services that you want to have, you would need to, use computing service, you need to use storage services, you need to use databases, and all of these things has to sit inside a VPC. So if you understand how all of these services can be used together,
VPC.
you will cover everything very, very fine. Yeah. Yeah. But if we spend time and just stock up on one service, yeah, but by the time we end the month, you would see that you still do not know how all of these things, work together. So we'll be looking at this from the project standpoint. Yeah, I've seen that actually works better. Uh, all right. Are there any other questions before we call it a night or a day? Again, you guys, today it's I don't want to say it was boring because we covered quite a number, but if you are used to all of these things, it might want to get boring. But again, we won't have this
So,
much time. Yeah, go
I
ahead.
think, sorry, I just needed to know, based on this career path, the cloud engineer, the DevOps engineer, the cloud support engineer, and all the possible career paths within this DevOps journey, right? The areas we are going to cover, right? Which of this area is it going to take towards? Which one can one at the end of this journey can one look at himself and say, okay, if having mastered all this, what what would I qualify to call myself? What do I qualify to call myself after this? Then what are the extra things I need to do to build on to possibly move from one career path on this DevOps to a different one?
Okay. Good question. So ordinarily, like I know I mentioned this as a caveat, from the onset that a month to learn cloud computing is will just be scratching the surface. But the part in which we'll be taking in this bootcamp is that we'll be so what the curriculum that we have here is, well, after if we follow it, say you want to learn all of those things, you'll probably just be you will be prepared to maybe take the cloud practitioner solution, which is very, very foundational. But because this is a DevOps bootcamp and most of the things you'll be doing, in DevOps is revolved around, your knowledge of the cloud. Yeah. So again, this would set you up for, and then before we start all of this, this was born from, the time spent in training folks, those that were taught without have given the that understanding of learning how to both come up with your own infrastructural diagram and then reading infrastructural diagrams, which is more tailored towards the solutions architects field, actually thrive better in the cloud compared to those that did not. Yeah. So and that has been the approach I've been taking thus far. First, introduce you to architectural diagrams, how to both come up with your own architectural diagrams and then read architectural diagrams. With this, you would see that every other role, what's the cloud engineer, then when you build on that, you're able to, like I said, most organizations, you probably will be wearing multiple hats. Yeah, but the goal of this is to introduce, to make you as familiar, for this first month, familiar with different cloud services and see how they all work together. Yeah, that's my goal. So you can, you definitely need to, depending on your interests, you will be doing a lot of self-study, especially for the different services that you will be introducing you to. We'll be using it again as part of a project. If I say I want to cover those services one after the other, you would leave this module, and then by the time we start talking about other things, you start talking, yeah, we are still trying to see how all of these things fit together, basically. Yeah. So to sum up your question, or to try to make sense, give you clarity, I'm going to try to build you up to be proficient in solutions architecting and in also cloud engineering. Come up with an architectural diagram and then also deploy it. Yeah. Oh, yeah. So DevOps still builds on all of this. Yeah. So DevOps is still, you would at the end of this bootcamp be very, very confident in calling yourself a DevOps engineer. I would say again, I've had trainees that after the cloud, after infrastructure as code, that's the second module already, we're going into interviews. Yeah, so yeah. Are there any other questions? Bliss, did that in a way give you, don't worry, you will get all that. Yeah. You enjoy your money that you pay to mobile. You're in very, very good hands. All right,
This is
guys.
my question.
Yeah, okay. CloudFront and I'll be part of our project. Yes, I know you have been pulling for this, so it's probably going to be one of the things we'll touch on it tomorrow, so that you can be unblocked. I know.
Thank you.
Yes, definitely. Yeah, we can't do without talking about Route 53 and CloudFront. Hopefully, your network will be better tomorrow.
Thank you. Thank you. Okay. Yeah.
All right, guys. Thank you for your time. I'll be seeing you all tomorrow.
Thank you.
Thank you.
All right, good night.
But okay, yeah. Can we talk for a minute? Guys.
Okay. Let me just stop the recording and then.
Yeah. Sorry, I sent my number in for the group to add me.
Okay. I think it's Taiwo that set up that